Greetings, everyone. Today we're going to explore power to a power as well as with a product or a quotient. Now, you do want our notes foldable for this, but you can always jot these down on your own notebook paper. All right, first let's take a look at the rule for power to a power. Power to a power rule says that we are going to distribute the power to the other exponents. Oops, sorry about that. And when we do that, we're going to follow sort of that basic distribution rule of multiplying those numbers, those exponents, when we distribute them. So for a numerical example, if I have 2 squared to the third, I'm going to distribute that cubed onto the squared, and when I do that, I'm going to multiply them to get to the 6th. Now, if your base is a number, of course, keep going. I do want to see that final numerical answer. If it's a variable, simplify all the way down. Let's talk about why. Why is that a rule? You don't have to write this down, but remember, if you ever get stuck, you can expand, meaning this 3 means I have 3 of these, right? Okay, well, these squareds mean I have 2 of them. And if I count, how many times am I multiplying m by itself? 6 times. So by a quick expansion, it reminds me, oh, that's how I got 2 times 3. Let's try again. If I have 2a to the fourths, okay, if I have 4a's times 4a's, how many times am I multiplying a by itself? 8 times. That's how I got the 8. 4 times 2. All right, here's the examples that are in our notes. The first thing I want to do is have you expand at least one problem. So please expand this one problem in your notes. We won't expand all of them, just this one. So this means I have 3 of these, right? We're multiplying things by themselves 3 times. 2 times 2 times 2 is 8. And if I have 2x's, 2x's, and 2x's, I've multiplied x by itself 6 times. So if you forget a rule on an assessment or even on a state test, expand it for a moment or create a little example to expand to help you remember the rules. All right, let's go really basic. We're just going to straight follow the rule. An exponent of 7 to the third becomes an exponent of 21. The fact that it's negative does not change the rule. A power to a power we multiply. I have negative 14. Now, knowing our previous rules, if you need to see my previous videos, we cannot keep an exponent negative. If it's on the top of a fraction, we kick it to the other side of the fraction bar to make it positive. Same rule. We're going to distribute, and when we do that, we multiply. A negative times a negative is positive. Be careful here. This first piece has nothing to do with that exponent of 8, so just drop it down. Next, let's deal with this piece. The negative 8 is being distributed onto the 2, so we have a negative 16. Next, I'm multiplying like bases. When you multiply like bases, you add their exponents. And the last rule says we can't keep things negative. We can't have a negative exponent. So if it's currently a numerator, we're going to kick it to the bottom and make it a denominator to make it positive. Similarly here, we're going to drop down b to the 5th. I can't use it yet. Let's deal with the parentheses. I'm going to distribute negative 4 times negative 5 is positive 20. When multiplying like bases, we keep the base and add the exponents. All right, let's take a look at the next tab in our foldable for power of a product. Meaning, what if I'm multiplying pieces inside of the parentheses? In this case, it's the same rule. We are still going to distribute the exponent of a onto the exponent, in this case of 1, The only difference here is just make sure that every piece gets that exponent distributed. So let me apply it with some numbers, makes it a little bit easier. That 3 has an exponent of 1. Well, 2 times 1 is 2. The 2 also goes to this exponent of 1. 2 times 1 is 2. From there, you can simplify, for example, 3 squared. We can take care of that and make it 9. So it's the same rule. We're still distributing. We're still multiplying exponents. It's just we have to do it multiple times. So before we get into the examples, let's see the why. What if? Let's practice expanding. I have 3 of these because it says 3 on the outside. So if I have this grouping 3 times, that helps remind me that I've got 4 A's here, 4 A's here, 4 A's here. So how many times am I multiplying A by itself? 12 times. I have 2 B's, 2 B's, and 2 B's. How many times am I multiplying B by itself? 6 times. So now that makes sense. Oh yeah, 3 times 4 gets me the 12, and 3 times 2 gets me to the 6. So if you're unsure and it's a small exponent, expand to remember. So let's start off with a simple example. Again, this is in your foldable. We've got exponents of 1. Sometimes it's helpful to draw those ones first so you don't forget about them. So 2 times 1 is 2, and 2 times 1 is 2. How many pieces do I have here? I have 1, 2, 3 pieces. This 3 has a 1 and this M has a 1. So I have to distribute 3 times. 3 times 1 is 3. 3 times 1 is 3. And 3 times 2 is 6. Now, if you can simplify 3 to the third, I can, then please do so, and bring everything else down that you are not going to use. Another one where I have 3 pieces. The 5 has a 1 and the Y has a 1. 2 times 1 is 2. 2 times 2 is 4. And 2 times 1 is 2. As always, if you can simplify, do so. 5 squared is 5 times 5. The x falls down, the y falls down, nothing special about those. So I'm done. Now notice this one has a negative out front, so let's temporarily ignore that. Technically it's a -1, right? So I'm just going to drop it down and leave it. Let's worry about the parentheses. The 2 has a 1, the x has a 1, the y has a 2. Let's distribute. 3 times 1 is 3. 3 times 1 is 3. And 3 times 2 is 6. Let's take care of the numbers here. 2 cubed, 2 times 2 times 2 is 8. Well, if I'm timesing it by a -1, it becomes a -8. So in the end, that negative just fell down and hung out out front of the problem. All right, what's the first thing your eyes are drawn to here? Z to the 0. Remember that anything to the 0 power is 1. So because we're multiplying, we get to just cross it off. So I'm going to rewrite this problem then to show you that we actually only have 3 pieces we need to care about. The 2 has a 1, the y has a 1. So now it's the same thing. 1 times 3 is 3. 3 times 3 is 9. Be careful of that. And 3 times 1 is 3. Let's take care of 2 cubed, which is still 8. Everything else hangs out. And again, if you can write it alphabetical, that would be the ideal. All right, let's talk about power of a quotient. This rule is the same rule. Hey, now we're just saying we want to distribute to every exponent, whether it be on the top or the bottom. So let's see why, okay? let's take a moment to expand. You don't need to rewrite this. What it means is I have x over y 5 times. Oops, I wrote 5 because I said 5. All right, 5 times. A little bit annoying to write it 5 times. That's why we have our rules. So how many times am I multiplying x by itself on top? 5 times. How many times am I multiplying y by itself on bottom? 5 times. So you can see why we would just distribute to both. What if there's a number? All right, this means I'm going to have this fraction 3 times. M times itself 3 times, 2 times itself 3 times, and as always, if it's a numerical numerical base, simplify it. So again, this proves why we distribute the exponent to both. So here's how I'm going to look at this. This 4 has a 1, that's a piece. This x has a 2, that's the exponent. And now I have a denominator that has an exponent of 3. Let's distribute to all 3 pieces. 2 times 1 is 2. 2 times an exponent of 2 is 4. 2 times an exponent of 3 is 6. Then I see that 4 squared can be simplified. 4 times 4. Can't do anything with the x and can't do anything with the y. All right, let's take a look at another one. I'm going to prep my fraction bar. If I take a look at the first, or the numerator, I have an exponent of 3 times the exponent of 4, which gets me 12. Look at that denominator, though. Technically, that has an exponent of 1. An exponent of 1 times an exponent of 4 is 4. Now, the a to the 12th is going to stay. I can't do anything about that. But that denominator means 4 times 4 times 4 times 4. That's going to be quite a large number, so make sure to use your calculator, but we're going to arrive at 256. Ooh, we're getting a little busier here. I have 5 pieces. The 2 has a 1, the x has a 1, the y has a 1. The 3 has a 1, the x has a 2. Let's get to distributing. All right, an exponent of 3 times 1 is 3. An exponent of 3 times 1 is 3. An exponent of 3 times 1 is 3. Bear with me. Denominator. An exponent of 1 times 3 is 3. An exponent of 3 times 2 is 6. We have 2 more rules to apply. The next rule is let's take care of those numbers. 2 times 2 times 2 is 8. 3 times 3 times 3 is 27. There's our first rule. I notice the y is a single y. I'm going to leave it. Let's refresh our memory on dividing. When I divide like bases, I subtract the exponents. The shortcut from my previous video says it's going to stay where the larger exponent is, and when I subtract 3 from 6, I get 3. So we are going to start incorporating our previous rules. Please put a star by this one. I chose this example because it tends to throw students off. But I have exponents of 1, right? So negative 3 times 1 is negative 3. Negative 3 times 1 is negative 3. Let's look at this piece by piece. The base of 5 has a negative exponent, so I'm going to kick it to the other side to make it positive. The base of 2 has a negative exponent. It's on the bottom. I'm going to kick it to the top to make it positive. They are number bases. Let's simplify. 2 times 2 times 2 is 8. 5 times 5 times 5 is 125. Make sure if you can reduce the fraction to do so, but in this case I can't, so I'm done. We have 5 pieces. Let's get going. I have an exponent of 1. 3 times 1 is 3. I have an exponent of 1. 3 times 1 is 3. I have an exponent of 1. 3 times 1. I have an exponent of negative 2. 3 times negative 2. I have an exponent of 2. 3 times 2. All right, let's see what we can do next. Take care of that 4 cubed. 4 times 4 is 16. 16 times 4 is 64. The A can stay, nothing special. The B can stay, there's only 1, nothing special. Oops, I was color coding, wasn't I? The C though, the C is negative. We never leave negative exponents. I'm going to kick it to the other side so it becomes positive, and D to the 6th stays as well. Now, make sure, as always, you check Google Classroom, but we have officially gone over all of the exponent rules we're going to look at. So check Google Classroom, check my YouTube playlist if you need the other rules. Let me know what questions you have, but definitely keep working on these rules. And remember, quick little tip, how do I know if I'm done with a problem? There should be no negative exponents. There should be no 0 exponents. We should have 1 of each letter, right? Meaning if I have 2 Y's, I'm not done. And then now we're adding on no parentheses. If there's parentheses, we're not done. All right, you guys have a good one. Talk to you later.